And this graph is good to have because they break it up into each individual piece. So here in the middle, you've got 68%. So they kind of, since it's symmetric, if you divide that in half, you've got 34% are on this side, 34% are on this side. So they break it down for each individual region for you. So feel free to use that for your notes. You won't have to have that for your test because I'm not gonna give you the hard types of questions on these. On these, it's gonna be just 68, 95, 99.7. So here the 13.5, they said 95% are here. We've already got 68% here, so that leaves us with 27%. So if you divide that in half, you get 13.5% here, 13.5% here. So that's how they came up with those numbers. Is they just did a bunch of dividing things out and subtracting them and whatnot to get them. You don't have to go through and do all that work yourself. You can just use the chart, like I said. Quizzes and homework, you can use the chart. Tests, you won't need to because tests are going to be straightforward, 68, 95, 99.7. What you will notice is most of our values are going to be within 3 standard deviations. This is only 0.15% over here and 0.15% over here. So if we get something that's more than 3 standard deviations above or below the mean, and it's bell-shaped, those are going to be something that doesn't happen very often. So it's going to be very rare that we come up with something like that. Okay. And then they also say you can use the empirical rules based on sample data. So this is with population, with the mu's and the sigmas, because we have Greek letters. But if you have sample data, just say X bar and S instead, and it's the same thing. Okay. All right, so we've got 54 female patients of a family doctor, and this is their HDL cholesterol. And let's actually calculate the mean and the standard deviation. That's a lot of numbers. Sorry about that. Let me just come up to my L1 and clear it out and type those 54 numbers in. Bear with me. This isn't the important part, so if you want to skip this, you can. Got all 54 put in for mine. Once you have all of them in, to get the mean and the standard deviation, you'll go to Stat, Calc, 1-bar Stats. And I put them into L1, so I don't need to specify where I put it. And then they give me my X bar, which is 57.4. Hold on, let me see how they want us to do. Yeah, I think they do 2 decimal places. And if that's my mean, for this one, should it be a mu or should it be an X bar? This one's going to be a mu because they say that you're using the population mean. So we've got our population, this is everybody. So this family doctor has 54 female patients. So he's got all 54 of them. So we can go ahead and use mu because it is the population, it's not a sample. If we were looking at maybe, a group of family doctors where they've got a practice with, 8 doctors or so, then we would maybe need to do a sample because that population would be way too big. But that's our mu. So our standard deviation, what's that letter going to be? It should be a sigma because, it's a population, so we're using those Greek letters. So if we write out our standard deviation, when we come here, don't use the S, you're going to want to use the sigma, so it's going to be off by just a little bit. You can see now that our the number of data values that we put in, now it's 54. So these are actually pretty close to each other, especially if you only round it to 1 decimal place. This one's 11.8 and this one's 11.7. It's only off by a little bit. It was off by a lot when we only had those 3 for our samples. But this is a lot closer now if we have a larger data set. But anyway, so this should be 11.7 for our sigma. Okay, we also need to make sure that it's roughly bell-shaped. They have this nice little graph here, and that looks like it's pretty close. I mean, it's not perfect. You've got some dips down here and whatnot. It's not exactly symmetric, but you've got this peak in the middle, and it comes down on both sides. So it's not skewed, so we're going to say it's close enough. These ones don't have to be perfect. Just as long as it's not skewed one way or another, we're going to say it's close enough. Okay. So now it says determine the percentage of all patients who have HDL within 3 standard deviations of the mean according to the empirical rule. Well, that one we don't even need to use any of the data, right? So if we're looking at within 3 standard deviations of the mean, if you're within 3 standard deviations of the mean, you're at 99.7. So we don't even need to calculate anything for that. That one's just 99.7. That's not too bad. I think D is a little bit different. Okay, so D says, how do I have this? Right, okay, so for D and E on the very bottom of those notes, I've got another little graph right here printed out because I'm going to use that one. I'm going to label everything on that graph and then to try to figure out what my answer is going to be. So if I start out right here in the middle, this is my mu. So mu for us is 57.4. What was my sigma? So 57. Maybe I need to write it down here, sorry. Okay. So there's my 57.4. I'm worried about 34 and 69.1. I think maybe these numbers are off by a little bit because I think they used the wrong number. I think that was this example. I don't remember. Okay, I got to figure out where 34 is on here. So it's going to be over this way somewhere. So I'm going to go this way first. So to get from here to here, so from here to here, I'm going to subtract sigma. So I'm basically going to be doing 57.4 minus 11.7, 45.7. And I want 34, so that's not enough. So I need to go again, so I'm going to subtract sigma again. So I'm going to start now with the 45.7, and I'm going to subtract 11.7. So these become zeros. This is a 34, so that's what I want. So right here, 34. That's the number I want. So that's my 34. I found that. So 34 is 2 standard deviations below the mean. I found that number. Got to find the other one though, which was 69.1. And that's larger than the mean, so it's going to be over here somewhere. So if I come this way, here, I'm going to be adding sigma. So I'm going to do 57.4, and I'm going to add 11.7. 69.1. Is that the number they wanted? Yeah, okay. So it's right there. It's 1 standard deviation above the mean. Okay. All right, so this is what I mean about homework and quizzes are going to be a little bit different, and you'll just want to use this graph when you do them. When I write a test, it's going to be more like what percent are between 45.7 and 69.1, where your answer would just be 68. So these two are going to be the same distance from the mean. You're not going to have, you know, one that's 2 standard deviations and one that's 1 standard deviation. I'm not going to do that to you. So your answers, it's going to be always be 68, 95, and 99.7. The homework will have some like that, but they'll also throw some of these in there as well for you, just to kind of trip you up. All right. So if it was 57 45.7 and 69.1, those are one standard deviation, so one standard deviation is associated with 68%, that would be your answer. But on the homework, when you have this one where it's a little bit lopsided and it's not centered in your bell curve like you want, if you use this one, all you have to do is say, I've got this area, and this area that are in between my two boundary points. So if I just add those together, I've got 34% plus 34% plus 13.5%. 1.5%. I don't know if I did that right. I tried to write it. Let's make sure. Yeah, so 81.5%. So according to the empirical rule, we would expect approximately 81.5% of our data values to fall in between those two numbers. According to the empirical rule. So we'll say 81.5%. Approximately. And it's not going to be perfect because our distribution was not exactly bell-shaped. It was approximately bell-shaped, so it's not going to be exactly 81.5%. Part E asks us to figure out how many patients actually have data values between those two values, so between 34 and 69.1. You can go through to your original data values and just like circle how many of them fall into that category. But what I'm going to do, since I already have my stuff in L1, so I'm going to just order L1 ascending, and then it'll be easier for me to just count them. So in my calculator,